inverse functions is being able to solve equations, right? The way you solve an equation is you perform inverse operations. The way we solve a square root equation is you steer both sides. The way we solve the equation is both sides. Those are inverses. So part of that is kind of really important in terms of solving trig equations, knowing that how do you get rid of sign, you use inverse sign. But really, really important that if you want things to just cancel out, it has to be over those specified domain ranges that I gave you yesterday. Which means if you're not sure, you might have to do a little bit more work to figure some things out. Right? Like we know if I take the square root of x squared, they're inverses, they just cancel out and I get x back. Well, the same thing is going to be true if I take the sine of arcsine or the arcsine of sine. If I do the inverse with the function itself, it should cancel each other out, but only over the specified domain range. So notice the x is in here, and we talked about that arcsine of x, the domain are actually the values. So that means these numbers have to be between 1 and -1. And if that's true, then I just get x back, right? It cancels each other out. It's like the best problem ever. But I also have to make sure that for the angles, right, if I'm given an angle, it has to be in that specified range of -π½ to π². And if that's true, and I take the arcsine of sine of some angle, then it will just give me y back. But we're going to look at some examples of when it doesn't just give you y back, and why you really have to make sure you're thinking about it as you do these. And so we can say the same thing for all of these. These are just kind of reviewing those specified domain and ranges I gave you yesterday. Cosine is still between -1 and 1, but remember for cosine, your angles have to be between 0 and pi. Sorry. I just wanted to make you have to write something. And again, if you meet those requirements, then they just cancel each other out. So the cosine of arc cosine of x is just x, and the arc cosine of y is just y. Definitely there'll be a question or two on your test that should be that simple, but there's also going to be some mixed in there that aren't that simple. So we want to make sure we can kind of distinguish between them. In our little real number symbol, right? If x is a real number, remember we said tangent, the domain of arctangent is all real numbers, and so x can be anything as long as it's a real number. But the range has to be between -π½ and π². And again, if that's true, then they just cancel each other out. Not true, you have to think about it for a minute. What could I do to work that out? That's going to mean that it's undefined. It just means that you're not necessarily just going to I don't know. No, you're right. I don't know why. It's like I didn't use the math stuff there. Like that's under my math. Make it correct, and it should be. Okay, let's practice on. I don't know why I asked like So my advice is if you're not sure if it meets the restricted domain and range, you can always work it out step by step what's going to happen. I have to do it both ways on this one. So like on this one, if you're saying, oh, 1 is in the specified range there from -1 to 1, that's true, which means this should cancel each other out, and I should just get 1 back. It meets the requirements. But on the test, you're not going to have those requirements listed out for you. So if you don't know them, you can just do this problem, order of operations, start with the inside, work your way out. So start with this, like you did yesterday. This is saying what angle has a sine of 1? What angle has a sine of 1? Pi halves. And then you do the outside function. What is the sine of pi halves? 1, right? Like, so you just canceled each other out, which is why you get 1, whether you know the rule or you don't know the rule. What happens on every test is people get really excited about this rule, and then they want to do that every time. So like on number 2, people give me an answer of 7 pi halves. But 7 pi halves is not the right answer Because 7 pi halves is not in the interval from 0 to pi, right? And so this is where you have to work it out. And so my advice to you is, if you're not sure, just work it out. So always inside first, step 1 would be, what is the cosine of 7 pi halves? Again, you haven't been reviewing your unit circle, and you feel like you forgot it, or maybe you never really learned it. This is the time that you want to spend the next few days doing that, because that no calculated part of the test is almost, if it's about half the test, is going to be all about these unit circle values. So 7 pi halves, that's more than 2 pi, so we could subtract 2 pi if you want. Or you could just think about that's 3.5 pi. Is that true? 3.5 pi. Think about what that would be. This would be 2 pi. This would be 3 pi and a half pi. Right? However you want to do it. Subtract 2 pi. It's going to go around. What would the cosine be at 7 pi halves? Cosine is x, and on the y-axis, x is always 0. So this would be the same as just saying 0. And then you do the arc cosine of that. And so this is why the answer is not 7 pi halves, because when you do arc cosine, you can only give me answers between 0 and pi. So what's the only angle between 0 and pi that has a cosine or an x value of 0? Pi halves. People maybe kind of can think through that without doing it step by step, and that's okay. Maybe you say 7 pi halves, 0 pi, that's half pi half. But if you do that, that's okay. But it always works if you do it step by step. So that's my advice to you. And then you're going to see questions like this. Sine and cosine do not cancel each other out, inverse cosine with sine. Which means if you see two different trig functions, it's just making you practice your unit circle, practice your order of operations, work from the inside to the outside. And so, kind of a little extra than yesterday, now it's going to ask you to take the inverse cosine of something, and then take the sine of that answer. Which means you really have to know your circle, your angle values. What angle between 0 and pi, because that's the restricted values for cosine, has a cosine of radical 3 over 2? That's true. Radical 3 over 2, 1/2, and cosine is your x. So that means pi 6. But unlike yesterday, there's something on the outside now. So now they're going to ask you to take the sine of pi 6, which means I already drew it over here. Here's my point. So the sine is just the y value. So my answer here is just 1/2. I think it's a great way to do would definitely be on a no calculator part of the test. So try number 4 if you haven't already. Notice it's different, right? Like on this one, it was inverse first, and then the function on the outside, so your answer is value. On this one, it's the angle on the inside, and then the inverse on the outside. So sometimes you're going to get angles for answers, sometimes you're going to get values for answers. On the outside. So take a minute there, do the cosine of pi thirds, and then take the arc sine of that one. points right up there. So if this is radical 3 over 2, 1/2, that means that pi third is 1/2 radical 3 over 2. So the cosine is x. And that's just like what was on your homework yesterday. What angle has a sine of 1/2 between pi halves and negative pi halves? Yes. So your answer here is the angle, because our sine's on the outside. It's just a function on the outside. Your answer is valid. Questions? They tend to be the well, that one worked out to be. Okay, so what else can we do to make life more exciting? What if we throw some x's in there and not actually? So it says find an algebraic expression equivalent to the given expression, which means we want to take the trig out of this and just write it as an algebraic expression. So I drew a triangle here because we're going to go back to the idea of what does this mean in terms of triangles. So this, we can stop the tangent for a minute, it's still important. But right now, if we just look at this part, this is like saying the sine of some angle equals x. Agree with that? That's what arc sine of x means. So if I drew a triangle over here, and I labeled one of those angles theta, not the right angle, but it doesn't matter which angle you label. I'm going to label this one up here. If I labeled this that angle that I don't know the value of it, I know the ratio for sine, right? I know sine as pi over r, or we could go all the way back to SOHCAHTOA, and we could say we know sine and opposite over hypotenuse. So if I call this theta, could I label the opposite side x and the hypotenuse 1? Does that triangle represent that equation now? That theta now? We could do this with numbers as well. They just like to do it with x's, kind of to make it more algebraic. But if I know this side is x and this side is 1, could I do Pythagorean theorem and figure out what this side equals in terms of x? Could. It's not going to be pretty. It's got a square root in it. X in it. Be much nicer if this was a number and then you could actually work it out. But I could just do Pythagorean theorem here. I'm going to show a little bit of work on this one. But I could say 1 squared equals x squared plus this side that I don't know. I'm going to subtract the x squared over. And I'm going to take the square root of both sides. And I get that this side would equal the square root of 1 minus x squared. And I know you really want to break that up because 1's a perfect square and x squared is a perfect square. But you can't break addition and subtraction up under a square root. That doesn't simplify anymore. It's because when you factor that, it's 1 minus x and 1 plus x. So it doesn't just cancel out. So just be really careful on that. You're not going to separate it when you do that. Questions on how I got that. So I took my trig function, drew a triangle, labeled it, solved for the missing side. I don't know what theta is. Like on the last one, I could find it. I could solve for the angle and say it's pi thirds or pi sixths or whatever. But on this one, I don't know what it is. But the answer to this is whatever theta is. You agree with that? So 30 degrees, the answer would be 30 here. But I don't know. So what's really cool about this is I don't know what this is. But the answer is whatever theta is. Right? The answer is what angle has the sine of x? Well, it's theta. So now what's great about the triangle? Can you tell me the tangent of that theta? Alright, we got all this stuff with unit circle and wrapping, and now we're kind of going back to basic triangles here of saying tangent. Tangent is opposite over adjacent. So I could say that this is the same as x over the square root of 1 minus x. And what have we done here? We've taken a trig expression and we've turned it into an algebraic expression. Mostly just to make you think about what it represents. If you work through it. We could rationalize that, we could bring it up, but it doesn't really look any better when you bring it up, and so this is where I usually just leave my square root at the bottom here. Nothing's going to cancel out. How do you feel about that? Excited? Because remember yesterday when we did this, like I really should have that PG on this still, but I just kind of disregarded the PG for a minute. But remember yesterday when we talked about this, this is like saying, yesterday I wrote question mark. When I see this, I can really think that that's like the sign of what equals X. Right? Remember what I did that yesterday? Like if we go back to the original one here, I could say this is like saying the cosine of some angle equals the square root of 3 over 2. I was just rewriting it so that we could see how we could put more triangles. You don't need to rewrite it, you don't have to. I just labeled it this time instead of a question mark. I actually didn't put it yet so that I can go with that. Other questions about that? In my Math 137 class, they do this, but then they also do it with just fractions. Like we had one where it was like arc sine of 3/7. And so we had to label this as 3 and this is 7 and actually find the third side and then find another value of it. So our book doesn't make us do that, but it's the same idea, just with numbers instead of variables. Have another one of these on here? So the idea when you see the ones with X's, like for me, when I see there's an X in it, I know I'm not going to get a number in my answer is going to also have X in it. The direction that they write an algebraic expression is kind of a big hint there that we're not going to get the solution here. We're just going to get another expression that has X in it. And every time, this inverse part on the inside, and it's always going to have inverse on the inside, you should be able to draw a triangle that represents that. And this one's also sine. It's not always going to be sine. But again, that's like saying the sine of some angle that I'm just choosing to call theta equals 2x. So this is like the value, and I'm trying to find what angle that is. I'm never going to find the angle, but I'm going to be able to draw the triangle, and I can label whichever angle I want as theta, and I can label it. I can do Pythagorean theorem on the side. About the ratios. Sine, again, if I label this one theta, then my sine would be, this would be 2x, this would be 1. Whenever you know the hypotenuse and you don't know one of the legs, you're always going to be subtracting the hypotenuse squared minus the leg squared, so I kind of tend to do that all at once. That's going to be 1 squared minus 4x squared. Be really careful, don't forget to square both the number and the x, right? 2x squared is really 2 squared and x squared. And then I have to take the square root of that, right? You're always going to get these radical expressions when you do this. Whether the hypotenuse is the radical or this. You have questions on where I'm getting that? And then again, if you have the picture, now all you have to do is find whatever trig function they want you to find out there. And on this one, they want me to find the cosine of that angle. So I can just look at this picture now and say, what is the cosine? Cosine is x over r, or adjacent over hypotenuse. And really nice on this one, the hypotenuse is 1. So when I put something over 1, it's really which means I get an algebraic expression that represents that trig expression of it. Tomorrow, the only thing that we haven't really talked about a little bit in this chapter for is the story problems with right triangle spreading. There's so many applications that you can use triangles in real-life problems, so that's what tomorrow is about. You can do a little of that. The big thing on that is that there's no picture. You have to draw your picture anyway, right? You can talk about like with elevation, if you're getting something like how we do that. So here's your homework for today. Not as many as yesterday, but it's still not that much time, and you actually have some time to work before. If you have questions for yesterday, okay, good news. I'm going to pass those packets back. They were out at 10 points, and so if you didn't do well to go, if you have questions, please ask me, because that's going to be good to let you know how you did on the graphic stuff. And then I'll finish up tomorrow, and then